Babalo, good evening. How are you?
Good morning, yourself.
Thank you. I was just confirming if you can hear what I'm saying. Thokozani, can you hear me? Hello? Thokozani, can you hear me? Can you confirm, please?
Yes, I can hear you, man.
Thank you. Right. I think colleagues were going to start. Our intention today, we're going to complete the electrodynamics, which is the generators. Then in our next class to follow, I am intending to go to the next topic. If you can approve that after today's class, could what will be our next class for next week? Either chemistry or physics. Right. Let's from Thokozani first. How far are you with the generators with the electrodynamics at your school?
We are done. We are currently doing
You are done.
Electric.
Okay, you are going to photoelectric effect now.
Yes.
Babalo, how far are you at your school?
We are also done. We're just doing revision.
You are doing what?
Wishing.
You are doing electrodynamics.
No, we are doing revision from mechanics.
Mechanics, which mechanics, dear? Because this term, you grade 12, there are only 2 topics for term 3, which is electrodynamics and also photoelectric effect. Then there is the chemistry section, which is the galvanic cells and electrolytic cells. So when I say mechanics, which part of mechanics are you still doing?
We are doing a revision, ma'am.
Oh, you are done with everything now?
In physics part, we are doing a revision.
Oh, physics, you are done?
Ma'am.
All right. So which means today I'm going to touch electrodynamics. So when we next time, I'll go to galvanic cells in the next week's class. I will jump photoelectric effect if you're done with physics. I'll go to chemistry, electrochemistry, galvanic, and electrolytic cells. Right. So which means today's class is gonna be very easy for us. There's a first question which was having 7 marks, which we were saying a simplified sketch of a generator is shown below. So you are having a generator which is there, which has got slip rings, which has got slip rings, 2 rings which are separate like this. Then the first question was saying, is the output voltage AC or DC? This one, it is in AC or DC. What is our answer, Thokozani?
It's a AC.
Is the AC. So I say AC because it has got slip rings. It's an AC, give a reason. It has got slip rings. It has got slip rings. Then number 2 is saying what type of energy conversion takes place in the above generator. As long as a generator, what type of energy conversion takes place there? You are talking about what? Mechanical to electrical. Mechanical to electrical. As long as a generator, mechanical to electrical. Then the next question is saying state 2 effects on the output voltage if the coil is made to turn faster. What is going to happen to output voltage, Thokozani? If you make the coil to turn faster, what happens to output voltage?
Does it increase?
What? Yes, it will increase. Output voltage will increase. Why? Because the number of cycles, or we can say frequency, increases. It will increase. Why? Because the frequency increases. Or we can say the number of cycles per second increases. Then the last question in that note was saying, what is the position? What is the position of the coil? In this position shown, what is the position of the relative to the magnetic field when the output voltage is maximum? When the output voltage is maximum, are we having the magnetic field parallel or perpendicular to the coil? What do you think there? Because if the magnetic field and the coil, they're having maximum point, are they parallel or are they perpendicular to each other? You're welcome, Lita. You're welcome, Kanyisa.
Thank you, ma'am.
So if we're having a maximum point, what does that mean? It means the coil is parallel to magnetic field. If the two are parallel, then we've got a maximum point in our graph. If the two are perpendicular, meaning say the coil and the magnetic field, then we've got a minimum. If the coil and the magnetic field are perpendicular, then we've got a minimum in our graph. Remember last time when you draw a sketch graph of an AC generator, something like this. These points here, where I'm crossing with an X, we call them maximum point. It means the coil is parallel to the magnetic field. These points here, where I show with a red cross, there we go. That one with a red cross, it means the coil and the magnetic field are perpendicular to each other. We have got the minimum. Voltage is 0. We have got the minimum. Lita, are you following? Right. Let's continue to the next question, colleagues. Let's continue to the next question. There's a question which is showing electric motors are important of many modern electrical appliances. AC motors, they are used in washing machines. That's how in the exam we must know the use of motors in the washing machines, in vacuum cleaners. DC motors are used in toys and some tools. So we're talking about a motor now. First question say, what energy conversion takes place in an electric motor? What energy conversion takes place in a motor? What type of energy conversion takes place in a motor? A motor, remember I said, it converts electrically to mechanically. As long it is a motor, whether it's a DC motor, whether it's an AC motor. Kanyisa, are you following?
Yes, ma'am, I am following.
Okay, thank you. At your school, are you busy with generators or are you done with them?
We are done with this one. We are at the photoelectronic
Photoelectric effect. Okay, so which means after I do this problem, I'm going to introduce the galvanic cell within this class, because I can see most of you guys are done with the generators. So after I do this last question, I'm going to jump on to the chemistry section, which is called the galvanic cell. I think that's going to be fair enough. Since you said most of you are done with this part, I'm going to jump on to galvanic cell after this last question, which you are doing now. Is that fine with you, Kanyis?
Yes, ma'am.
Okay. All right. Right. So I was saying, what is the essential difference between a DC motor and an AC motor? What is the difference between a DC motor and an AC motor? Remember, we can talk about a DC motor, then you compare it with an AC motor. The first thing, which is common difference, which you must understand, a DC is a commutator, or you can call it split ring. It has got a commutator. Then this one has got slip rings. Then in a DC motor, current reverse. Whenever the coil is in a vertical position, current is going to reverse. Current reverse when coil is in vertical position to the magnetic field, which means if it is perpendicular, then the current is going to reverse. When I say reverse, so I'm talking about this. A DC, remember, current is going in one direction. Right. Then in an AC, which is the alternating current, without a commutator, current alternates. To alternate means it changes direction after every half cycle. Current alternates after every half cycle. The current is going to change direction. Half cycle alternates, half cycle alternates. That is an AC motor. So you must be able to pick at least two differences, or one between the two. Then you get your nice 2 marks. Then number 3 is saying list 3 ways in which the efficiency of a motor can be improved. How can we improve the efficiency of a motor? How can we improve the efficiency of a motor? How can we improve the efficiency of a motor? How can we improve? Number 1, we say use stronger magnets. You can increase the efficiency of a motor by using stronger magnets. What else can we do, colleagues, besides using stronger magnets? What else can you do to improve the efficiency of a motor? You can increase the number of turns. Increase number of turns in the coil. Number of turns in the coil. You also improve efficiency by increasing the number of turns in the coil. You can also increase the current. Then you are increasing efficiency of the motor. So in the exam, we expect you to know at least two ways. How can you increase the efficiency? Efficiency means operational aspect of the motor. Right, last question 4 in that regard. Consider the diagram. The conventional current is indicated as by the arrows which you see. So which means our motor is something like this. Then we have our current, which is being shown going in like this and going out like that. So the question says, in which direction, clockwise or anti-clockwise, would the coil or the armature rotate? Can you see current is going clockwise like this? Always the coil is opposite direction to the current. always the coil in a generator, in a motor, is opposite direction, which means if this is going clockwise means you are going this way in maths, then the coil must be rotated anti-clockwise. It means the coil is going anti-clockwise. The coil is opposite direction to the current. Are we following, colleagues? Right. The last question says, why does the armature or the coil continue moving in the same direction once it has reached the vertical position? Why do we think the coil continue moving? The main reason, you can say, the coil's own momentum. The coil has got its own momentum. Why does it continue moving? Remember, when you stop something, Newton's law, which says inertia, or Newton's first law, let me say. Why does it say Newton's first law? We are going back to mechanics. An object will continue in a state of rest or continuous motion unless a non-zero net force acts on it. So which means what will make the coil to keep on rotating? It is because of its own momentum. Its own momentum. Its own momentum. It will keep on rotating because of its own momentum. Or you might say this, remember we say the split ring changes or reverse current every time when the coil reaches a vertical position. This is a motor. The split ring reverse current after the coil reaches vertical position. After the coil reaches vertical position. That's why in a DC motor, current is not reversing after every half cycle. Current maintains the same direction. When it is vertical position, there we go, this is a DC, where you have got a commutator. Anyone with a question, colleagues?
No.
Okay. I want to hear from you. Both like some people are getting in and out, maybe because of network. Lerato, I think I've asked you. Both I can see most of us were done with dynamics at our schools. Is that correct, Lerato?
Yes, ma'am.
Is that correct, Emina?
Yes, ma'am.
Is that correct, Kozan? You are done also at your school, eh? Okay. So can you allow me to jump and I introduce the galvanic cell? Or maybe photoelectric effect, because I can see most of you are done with this topic. And it's something which must not take us so long. So when I prepare, I thought most of you are still here. But it won't help us to keep on doing the symbol and the symbol stuff. So I am going to introduce the chemistry, which is called electrochemistry, if you don't mind. I don't know, how do you feel, class? How do you feel, class? Or I can touch on photoelectric effect. Can I hear from your concerns?
Yes, ma'am.
Yes, meaning photoelectric or electrochemistry.
Ma'am, can we do electrochemistry?
Electrochemistry.
Galvanic, yes, ma'am.
Chokozani, are you aligned with us? Can we do electrochemistry?
Yes, ma'am.
Yes.
Okay, All right, that's fine then. So that I cannot waste time. I will try to do it so that you can gain something at the end of the day every time. I will just send one or two concepts on this one. Right, when we're talking about electrochemistry, it is a branch of chemistry that deals with two types of energies. From the word itself, you can think of what you call electrical energy, and there is chemical energy. So again, in this topic, we are going to talk about two types of cells. We are going to talk about two types of cells. Two types of cells. One of the cell converts electrically to chemical, and another one converts chemical to electrical. So the first type is called galvanic cell, or we call it voltaic cell. It's called a galvanic cell, or call it voltaic cell. The second one is called the electrolytic cell. Electrolytic cell. So from the word the electrolytic cell, this is the type of a cell which converts electrical to chemical. A cell that converts electrical to chemical energy. Remember, I said there are two types of cell. One is called galvanic or voltaic. One is called electrolytic. So if an electrolytic converts electrical to chemical, which can tell me the galvanic will convert which energy to which energy then? The galvanic cell.
It converts chemical energy to electrical energy.
Right. A galvanic converts chemical to electrical. A galvanic will convert chemical to electrical energy. A galvanic will convert chemical to electrical energy. So in the next concept, I want us to discuss differences between galvanic and electrolytic. I am going to give you 3 differences, if not 4. Please just remember 2, maximum of 2 in the exam. They will never ask more than 2 differences. I do mark paper 2 quite long. I'm a marker for paper 2, so they will never ask more than 2 differences at all. So the first difference is what we have already discussed. This one must tell us convert electrically to chemical. Then this one, chemical to electrical. That's the first difference. Then the second difference, which we must understand, this one you understand as we go, as we do questions. Anode is negative. Anode is negative. In a galvanic, anode is negative. Then in an electrolytic, anode is positive. This different, don't worry, you understand it as we do problems. Anode is negative. Anode is positive. Then the next difference which you can understand for now is we are going to discuss 1 or 2 questions. I'll post 1 or 2 questions on the group. This one, it is a salt bridge. Yes, a salt bridge. I would now definitely define what is a salt bridge as we discuss now. This one, no salt bridge. Electrolytic, no salt bridge. Last but not least differences, remember at least 2 in the exam, please. Not more than 2. 2 is fine. This one, it uses 2 electrolytes. It uses 2 electrolytes. This one uses 1. 1 electrolyte. This one uses 1 electrolyte. A galvanic uses 2 electrolytes. An electrolytic uses 1 electrolyte. Remember, an electrolyte from grade 9 is a solution which can conduct electricity because it has got free, or called the mobile ions. It has got free ions. An electrolyte is a solution which can conduct electricity because it has got free ions. Are we moving together so far, colleagues?
Yes, ma'am.
Thank you, Lerato. Right. Then from there, I want us to touch some few definitions. Then we'll discuss some questions now. I want us to touch some few definitions. Some of them, they come from grade 11. We have a lot of definitions here. But you must remember all of them in the exam. The first one is called oxidation. I know from grade 11 we've done this one as what? Loss of electrons. Or you can define oxidation as increase in oxidation number. Increase in oxidation number. Increase in oxidation number. We call it oxidation. Increase in oxidation number. Opposite of oxidation, colleagues, is what we call reduction. Opposite of oxidation is what we call reduction. So if you are talking about loss of electrons, when you talk about reduction, what are you going to say, Lerat?
Gain of electrons.
Gain of electrons, very good. Then you can say decrease in oxidation number. Decrease in oxidation number or gain of electrons. Good. So the next definition which will assist us in this topic again, I want us to discuss what we call anode and cathode. I will define one, then the other one is opposite. You can be able to explain for me what is that. Anode, you can just say it's where electrode, where oxidation takes place. Where oxidation takes place. Where oxidation takes place. Remember, oxidation is the loss of electrons. So, Tokozani, can you define cathode? I said anode is where oxidation takes place. What is cathode then?
Where reduction takes place.
Thank you. Where reduction takes place. Where reduction takes place. I am going to the next set of definitions, which are also looking like twins. Oxidizing agent. And there's what we call reducing agent. Oxidizing agent. I'll define oxidizing agent. Then Jemima will discuss for me a reducing agent. Right. What we call an oxidizing agent, please take note, a substance. A substance. Keyword, please. A substance that is reduced. A substance that is reduced. A substance that is reduced. Somebody who is reduced, it means it gains. Remember, a reduction, it means it gains electrons. So you can say a substance that gains electrons, or you can say a substance that decreases in oxidation number. Let me repeat this one again. I said the oxidizing agent can have 3 definitions. Can have 3 definitions. What is the key? A substance that is reduced. we call it an oxidizing agent, a substance that is reduced. Or we can say a substance that gains electrons. Or we can say a substance that decreases in oxidation number. All these three are possible definitions of an oxidizing agent, a substance that is reduced, a substance that gains electrons, a substance that decreases in oxidation number. So, Jemima, can you try to discuss for us a reducing agent? What is that? Let's try. What's a reducing agent? Jemina, let's try. What's a reducing agent?
Sorry, please repeat.
Okay. I'm saying an oxidizing agent is a substance that is reduced. Or I can say a substance that gains electrons. Or I can say a substance that decreases in oxidation number. Any of those three is correct. So I want you to discuss for me a reducing agent. It's an opposite of an oxidizing agent. A reducing agent is an opposite of an oxidizing agent. Can you try to define it? Lerato, can you assist?
Memo would say it's a substance that loses electrons and it undergoes oxidation.
Okay, I want to hear the point here. Remember, I said a substance that decreases in oxidation number. It's an oxidizing agent. What about a reducing agent? It must what in terms of oxidation number?
Increase in oxidation number.
Very correct. It must increase in oxidation number. It must increase in oxidation number. Then the last definition, colleagues, in our case here, the last definition in this topic, which we're gonna have is called electrode. Electrode. What you call an electrode? It can be a metal, or you can say it's a solid that conducts electricity. That conducts electricity. That can conduct electricity. We call it an electrode. It is a metal, or you can say it is a solid that can conduct electricity. So these are the definition which are key in our galvanic cell, which is question number 8 in paper 2. Are we all following, colleagues?
Yes, ma'am.
Right. So after that, only for today's class, I'm going to focus only on galvanic cell. I'm going to focus only on galvanic cell. Then in our next class, we're going to talk about electrolytic cell. So only today, I'm going to focus only on galvanic cell. Right. A galvanic cell operates under 3 standard conditions. I am going to quickly indicate the conditions for you now. Let me wrap this part. I'm gonna first of all talk about what you call standard conditions. There are 3 standard conditions for a galvanic. There are 3 for galvanic. Right. Number 1, we talk about what you call temperature. Don't just temperature in the exam. Temperature must be 25 degrees Celsius So when you mention the word temperature, you must put in brackets 25 degrees Celsius. Temperature must be 25 degrees Celsius. Condition number 2 is called concentration. You don't just say concentration, you say 1 mole per dm cubed, 1 mole per cubic decimeter. Concentration must be 1 mole per cubic decimeter. And last condition is called pressure. Pressure must be 101.3 kilopascals. Pressure must be 101.3 kilopascals. Pressure must be 101.3 kilopascals. Are we following, colleagues?
Yes, ma'am.
Right. So in the exam, pressure affects only gases. When I say pressure affects only gases, if you don't have a gas, I'm going to discuss now a question whereby you don't have a gas. You only mention the first two. You only mention the first two. Temperature, 25 degrees. Concentration, 1 mole per dm cubed. If there is no gas. Right. What do I mean if there's no gas? I want us to first of all start with an element called aluminium, Al3+. I'll explain what is this. Then we have another half cell, Mg, and Mg2+. Let's look at these two cells. When I say Mg, Al+, it means one of the container contains, remember I said the galvanic has got 2 containers. A galvanic has got 2 containers. So one of the container will contain aluminium. One of the container will contain magnesium. I'm not sure if you are very close to paper 2 question paper in somewhere close to you. If you don't have, I can say, but I want to have a paper 2 question paper close by you there. Can you just check a paper 2 question paper with formulas? Because I want to indicate some formulas which are there. Can I just give you 1 minute, 2 minutes, just quickly check for paper 2 question paper? Or you can open them from your tablets, whatever. If you have it with you, can you indicate so I have it? Then I can see that you all have them. If you have them, can you indicate I have it? Then I can know that you are moving together. Paper 2, any paper 2 with you.
I have it now.
Thank you. Lerato? I'm still waiting for others.
I have it, ma'am.
Thank you. Jemina?
Ma'am.
Do you have the paper 2 question paper with you?
Yes, ma'am.
You have it now? Right. If you have it, I love that. I want to check there are tables which are 10 table 4A, and there's a table 10 table 4B, something which has got elements with reduction potential going from lithium to fluorine. There's one which is in table 4A, there's one which is in table 4B. I'm not sure if you can see that one in your papers.
Yes, ma'am.
If you can see it, I love that. Right. So as we're going to discuss this topic, colleagues, I'm going to make use of table 4B. I'm going to make use of table 4B. Whatever I'm going to discuss here, I'm going to make use of table 4B. And I know as a teacher is going to teach you, some might mix 4A and 4B, but it's always wiser to stick to one table. I'm going to explain whatever I'm going to explain here using table 4B. Are we following, colleagues?
Yes, ma'am.
Yes. So if you check there, if you check table 4b, I want to check between the element aluminium and the magnesium Mg on the table 4b. Which element do you see first?
Aluminium.
Which element do you see first? Aluminium. Are we all seeing aluminium, colleagues? Aluminium, Al. Yes. Lerato, you see aluminium, right?
Yes, ma'am.
Good. So every time, colleagues, when you are writing the anode, so as you go down here, there are two arrows. One is going up, one is going down. So one is saying increasing, reducing ability is going up. Then there's one written going down, increasing, oxidizing ability. So every time when you write the anode, you reverse the anode. You reverse the anode. You reverse the anode. So as you mean by reverse, what I mean by reverse, can you see the equation? Can you see it like this in the paper? Let me quickly see how you see it like this in the paper. It is like this. 3 electrons, then there are 2 arrows, then it's aluminium. Can you all see that?
Ma'am. Yes, ma'am.
All right. Magnesium is written like this. It's somewhere down on the table like this. Can you see that?
Yes, ma'am.
Right. So every time when we write the anode, colleagues, every time when you write the anode equation, you reverse. To reverse means you start writing what you see on the right hand side. So you must write aluminium like this. Then you put a single arrow. Then you put aluminium 3 plus 3 electrons. When I mean by reverse, you write what is on the right first. This is always when I say write the anode, you reverse the equation for anode. Remember I said on the 4b table, anode is what you see first, the one which has got a higher reducing ability. Can you see that?
Yes, ma'am.
Then the cathode you write the way you see it in the paper. When I say the way you see it, can you see there's Mg2 plus 2 electrons? You now make use of 1 arrow. Don't use 2 arrows. Then you form magnesium. Are we following that?
Yes, ma'am.
Right. So this is called the anode or oxidation equation. You always reverse anode or oxidation. Cathode, you write the way as is on the paper, but please make use of 1 arrow. They are called half reaction. They are called half reaction. Are we fine with that, colleagues?
Ma'am.
Right. I want us to look for another element. Then you can see if you understand what I'm trying to talk about. I want us to look for another element again. Another set of elements. Let me look at set elements called the Ag and Zn. Ag and Zn. I want to quickly look at that table there. Tell me which one is the anode. Ag and Zn. Zn and Ag. Which one is our anode from our 4b table? Which one is our anode, colleagues? Which one is our anode?
Zn.
Zn. Are we all seeing Zn, colleagues?
Why is it because Zn, we find Zn before Ag.
Ag is down. Can you do that?
Yes, ma'am. Ag is down. We
Yes,
find
so
Zn before Ag.
good. So every time when you see Zn as being the first, the higher reducing ability, you reverse the equation anode. You reverse it. Which means when I write Zn, I write Zn, I put one arrow. I put Zn 2 plus 2 electrons. We call this one the anode equation or the cathode. Cathode you write as it is, sorry, anode or oxidation. This is called the anode equation. Anode, or you can call it oxidation. Anode, or you can call it oxidation. Anode you always reverse. Gemina, I said something.
Sorry, ma'am?
Are you saying something? Are you fine?
No, I'm fine.
Sorry? Right. Cathode. You write the way you see it there. The way you see it on the paper. Or you call it reduction. Cathode, or you call it reduction. Ag plus an electron. Then you call it Ag. Ag plus an electron. Then you call it Ag. That is reduction. So in the exam, they will ask you, write the anode equation or write the oxidation reaction. Are we all following, colleagues?
Ma'am.
And always in the exam, electrons in the external circuit, they flow from anode to cathode. Electrons, they flow from anode to cathode. That's why you've got electron flow. Remember, anode, there is loss of electrons. Cathode, there is gain of electrons. So they always flow from anode to cathode, electron flow in the external. External means outside, external circuit. In the external circuit, electrons, they always flow from anode to cathode. They are lost in the anode, they are gained in the cathode. So electrons flow from anode to cathode. Right. So after you are able to write the anode equation, anode you always reverse. Cathode you write as it is. Right. I want us to look at these two now. There's what you call now, after equation, anode and cathode. There's what you call cell reaction. Cell reaction. We call it net cell reaction. Net cell reaction. Net means total in science. Right. Before I do this one, I want you to check for me. Let me start with the simple one. Mg and Zn. Which one is the anode? Which one is the cathode?
Mg and what, ma'am?
Mg is the what?
The anode.
The anode, le right?
Zn means, ma'am.
We are on table 4B. We are on table 4B. Which one are you seeing first between Mg and Zn?
Mg is the anode.
From the top is Mg.
Oh.
4B,
Yes,
né?
Mg.
Mg,
Yes,
very good.
ma'am.
Yes. So Mg is the anode. So I want to explain the net cell using these two elements, both that easy to understand first. Then I go to the difficult one. So we agree as a class. We always reverse the anode. We always reverse the anode. And we use one arrow, please. You always reverse the anode. You always reverse the anode. Cathode, you write the way you see it on that 4B table. Cathode, you write the way you see it on that table there. So I want to ask something interesting, but it's now easier to start with, then I'll go to the difficult one. Can you see I'm losing 2 electrons on magnesium? I am gaining 2 electrons on zinc. Are you following, colleagues?
Yes.
So it means if you are losing 2 and gain 2, you are losing 2, you gain 2. The electrons will cancel each other because they are the same. They are same, 2 lost, 2 gains. Net means you are now cancelling because the electrons which are gained and lost are exactly the same. 2, 2. Now I am going to copy what is on my left hand side on the first equation. I've got Mg. On the second equation, I am left with Zn2 plus. The electrons are no longer there because they cancel each other. They were the same. On the right hand side, Mg2 plus Zn. You get your 3 out of 3. I want to explain this one again. Net cell reaction. Net means total. You are combining the anode, which we did right, and the cathode. You get what you call net cell reaction. So if the electrons are the same, they cancel each other. 2 lost, 2 gained, which means they can cancel each other. You copy what remains on the left-hand side for the first equation, Mg. You copy what remains on the second equation, Zn2 plus. You put your arrow. First equation, what remains on the right, Mg2 plus. Second equation, Zn. Are we all following there? Akai, did you pick that one up?
Yes, ma'am.
Lerato, did you pick that one up?
Yes, ma'am.
Tokozan, did you pick that one up? Okay. Jemima, did you pick that one up?
Yes, ma'am.
Good. Now because all of you say yes, the ones which I have mentioned a few, I want us now to go to a situation whereby the electrons are not the same. I want us to go to the situation whereby now, the one which you did on top there, where zinc was losing 2. But can you see on silver, it's only 1. Can you see the 2 and 1 are not the same? You must balance. You must balance the 2 equation now. You must have 2, 2. You look for what you call LCD, lowest common denominator. Yeah, 2, lowest common multiple, sorry, 2 and 1. It must be 2. So which means equation number 2 here, silver. I'm going to multiply everything by 2 because I want to have 2 electrons here to be exactly the same like this. Are you following on that one?
Yes, ma'am.
So if I multiply by 2, it means 2 will affect Ag, 2 will affect the electrons, 2 will affect the Ag plus. Everything times 2. Everything times 2. So now you can see now 2 electrons can cancel 2 electrons because now they're exactly the same 2, 2. Now I'm going to copy what remains after the electrons cancel each other. Zn plus 2Ag plus. Then we go to the right hand side. Zn2 plus 2Ag. I can only multiply if the electrons are not the same. If they are the same, they cancel each other automatically. So this is what we call net cell reaction. Net cell reaction. Let me give one example again for one which are not the same. Our first example was not the same. Aluminium Remember I said aluminium is the anode in our first example. Then say cathode was magnesium. I've got a situation like this now. How many electrons are lost by aluminium? There are 3. How many are being gained? There are 2. Can you see these 2 are not the same, colleagues?
Yes, ma'am.
So which means I want to make them the same. You look at lowest common multiple. First equation, I multiply it by what? You are doing maths, most of us. What is the lowest common multiple of 2 and 3? Which is the number for lowest common multiple of 2 and 3, colleagues?
6.
6. So which means first equation I multiplied by how much?
6.
By 2.
By 2. Because I want to have 6, colleagues. 2 times 3 will give me 6. Second equation I multiplied by what?
3.
3.
By 3. So if I say times 3, it means everything is multiplied by 3. This. If I say times 2, times 2, times 2, times 2, everything times 2. Now the electrons will cancel the electrons because there will be 6, 6. I don't know if you are following on that one. So which means what remains on the left side? 2 times Al. I'll have 2Al plus 3 times Mg2 plus. I am copying what is on the left hand side, please. Last, on the right hand side, 2 times Al3 plus 2Al3 plus 3 magnesium. The electrons are no longer there because there will be 6, 6. Because there will be 6, 6. They will cancel each other now. So this one is called net cell reaction. Net cell reaction. I'm not sure if you are following, colleagues. Is there somebody who is lost?
I'm following, ma'am.
Very good. Then I'm left with this is called net cell reaction. Always in the exam is 3 marks. Always in the exam is 3 marks. Always in the exam is 3 marks. I want to look at the second last. There are only 4 things which are asked in a galvanic. Anode or cathode equation, which is oxidation or reduction. After that, the examiner will ask net cell reaction. Net cell reaction. Or they can say balance equation. Net balance equation. Then the third thing, which you want to touch now, then I think the fourth one will be the last one. Then we're going to call it a night for tonight. After net cell reaction, there's what we call cell notation. Cell notation. Cell notation. Cell notation. I want to use the same examples which I have here. Then you can understand it better. The number 3 aspects is called cell notation. Cell notation. This one, you are using symbols. You are using symbols. You are using symbols for a galvanic. You are using symbols for galvanic. If you can quickly refer, I don't know if you are able to use the same gadget. There's a question which I throw just on the group, which have got Cu2 plus, Ag plus, and Ag. Can you confirm if you can check that one from your Edge gadget, please? If you can check that question quickly. It's if Cu2 plus with something written AB, something like a pipe like this. Can you see it, colleagues?
Ma'am.
Something like this, which I just throw on the paper.
Yes.
Right. This pipe which you see here, that is the one you are talking about, salt bridge. That is the one you call the salt bridge. So a galvanic cell, always you see a salt bridge. That is what you refer as a salt bridge. So can you see there are two containers? One contains silver. One contains silver. Ag plus is called silver. Ag, and it must have Ag plus. It's a solution. The other one is containing copper, Cu solid, and the solution is called copper sulfate. So I just want to explain the cell notation, then I'll lastly do cell EMF, then you call it a night. By cell notation, we're using symbols. I want you to check for me, those who are following up. Cu2 plus, there are 3 Cus in the paper, but always in the exam, you use the copper, which has got a value of 0.34 V. I want to check that copper in the table, which you have there. It has got a value of 0.34 V, but there are 3 coppers, when I must only choose the one with 0.34 in the exam. Can you see that 0.34, colleagues? Check in your table 4B.
Yes, ma'am.
Yes, thank you. So which means between copper and silver, which one is the anode? Which one is the anode?
Copper.
Copper. So I tell you, colleagues, anode, you always reverse the anode. You always reverse the anode. Copper, we use copper 0.34, please. Cathode, you write the way you see it. The way you see it on the paper. You are using one arrow. I just want you to understand this is still anode and cathode, but I want to explain cell notation using this example here. That's why I'm doing that. So cell notation, anode first, you write to Cu, this Cu. After Cu, you put one line which is straight. This line is called phase separator. Phase separator. Or you can call a phase change phase. Phase. PH. A phase separator is separating the phase from solid to aqueous. Then when you see 2 lines like this, that is a salt bridge. This one is called a salt bridge. A salt bridge. Then I come to the cathode last. Ag plus. This is what I see here, cathode first. One line means phase separator. Then we've got Ag. I want to repeat this. Cell notation, we are using symbols. Symbols. You save time. You don't now draw the whole diagram now. So you start with the anode first. You finish what's happening in the anode. Copper is a solid. You put one line. One line means phase change. You put Cu2 plus. Everything you see with a plus, it's a solution. It's called aqueous. 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 Anything with a charge is an aqueous solution. Double lines like this, it means a salt bridge. This one in the diagram. Then lastly, you do the cathode. Ag plus one line Ag. Are we following, colleagues?
Yes, ma'am.
I want to do the same with aluminium. Remember, aluminium was our anode. So if I want a cell notation, Al, one line, Al3 plus, salt bridge, Mg, 2 plus, one line, straight line please, Mg, is called cell notations. Cell notations. I'm using symbols. Anyone with a question on that one? I'm left with only one thing that will be done for tonight. Anyone with a question regarding this cell notation? Tokozano, are you following? Thank you. Lerata, are we together?
Yes, ma'am.
Good. Gemini, I know we're following. Then I'm gonna touch the last thing. Then I know the question which we have done, the first one which I sent, we have already answered every question. I'm only touch the last concept, then we can call it a night. After cell notation, there's what you call EMF, or call it cell potential, EMF. Or in the exam, they always say calculate cell potential. Calculate cell potential, P-O, potential, cell potential. It is always having 4 or 5 marks. Calculate cell potential. This one I'm not going to spend long, it's very easy. It has got a formula which says E theta cell. This formula given in the exam is equals to E theta cathode minus E theta anode. So you are going to check in the table there. We are talking about copper and silver. Remember that class we agreed silver is the cathode, copper the anode. So you are going to check the number which is on the silver. I think if you check it properly, 0.80, am I correct? If you check the number for voltage, which is for silver, 0.80, can you see that? Somebody confirm, yes, thank you. Minus the one for copper, remember I told you, please you use 0.34 copper. You use 0.34. You take your calculator. You minus the 2. 0.8 minus 0.34. What answer are you getting correct? Are you getting 0.46 V? Thank you.
Yes, ma'am.
Let me do the E theta cell for aluminium magnesium. First things first, please, you write your formula. E theta cathode minus E theta anode. You write your formula. So who is the cathode? You guys said it's magnesium, am I correct? Can you see minus 2.36 for magnesium? Is it minus 2.36? Which is the cathode, guys? What's the value for magnesium?
Cathode is aluminium.
Cathode is aluminium, thank you. Magnesium is the anode, right?
Yes.
So which means magnesium is the anode, thank you. Aluminium is negative 1.66. Minus for subtraction. Aluminium is magnesium. Which one for magnesium is minus 2.36? Am I correct?
Ma'am.
What is your answer, colleagues? Answer, please. Answer, please.
4.7.
4.7.
So which means you guys, we did not do proper the cell notation. If you are telling me magnesium is the anode, you are saying magnesium is the anode, right? Yes. So if the magnesium is the anode, so which means you guys did not betray me there. If magnesium is the anode, magnesium first. you write the anode first on the cell notation, which means you have to correct our cell notation there. If you are saying magnesium is the anode, aluminium 3 plus 3 electrons. Aluminium 3 plus, I forgot now, you say I'm mixing the two. Slash aluminium. Magnesium is the anode. Are we all following?
Yes, ma'am. Magnesium is the anode.
So why didn't you correct us the cell reaction when we're saying aluminium is the anode? I was just banking on you, which means our cell reaction is also totally wrong again. I said anode is the one which you reverse. Anode is the one which you reverse. Anode is the one which you reverse. You are using 4B table. Anode is the one which you reverse. Please take note of that. Anode is the one which you reverse. Cathode, you write the way you see it on the paper as is. As is. So if I want cell reaction, it's still the multiply by 3. It's valid 3 Mg plus 2 aluminium 3 plus. Then you get 3 magnesium 2 plus 2 aluminium. Please correct that cell reaction. You were supposed to tell us which one is the anode, which one is the cathode. Take note of that. So cell reaction, you are balancing the equation. Cell notation, you are using symbols. Cell potential or EMF, you are calculating the EMF. Then you want to end here for tonight. So as we discussed, the first question we've done everything which is needed there. The second question, which I post on the group, you can try it on your own. Next time when we meet, please, when I always say, can you indicate which topic are you doing? For the sake of me to know what is the plan for my next class. If you don't log out or tell me what are you doing at school, it always gives me a challenge. Like today, you see, I have to switch the topic during the class because I didn't know what were you doing at school, what are you done with. So please, as you log out today, indicate the topics you are done with. Electrodynamics, photoelectric effect, busy with, you say galvanic. Okay, say busy with photoelectric. Then I can know what to target next class. Am I clear the log out details, colleagues Lerato?
Yes, ma'am.
Yeah, dynamics done, photoelectric done, busy or doing electrochemistry. Then I can know in my next class I can project it after a week before we meet. What must I plan? Then you cannot repeat the same concept which you are done at school. It won't benefit you. Thokozani, is it clear the logout details for tonight?
No.
Thank you very much, colleagues. We'll meet you in the next class. Have a good night.
Good night, ma'am.